Hi everyone, welcome to the next video. I hope you're all doing good. In this video, I'll be talking about two critical features in browsers that keep you really safe, which you might not even know about. So one is SOP and the second one is CORS. So I'll be discussing about both of these and then I'll be giving you an example by going through a CVE as well. So let's get right into it. I haven't created a presentation or anything because I wanted to show you some of the stuff what's happening. Essentially, I'll be telling some details on what SOP is and what cores are. So SOP or same origin policy is a security that is implemented by the browser. Let's take the case that you are already logged into your banking website. You have already logged in, you can view your accounts and things like that. What if you open up another tab and go to a malicious website which actually is, let's go through this code, which is actually, so this is your bank's API for transfer the money. What if and think of this as the evil website's code. What if the evil website actually tries to send, in JavaScript you can use fetch to send requests. So what if it tries to send a request to the bank's API to transfer the money? Think that you are already logged in, so, and it is able to transfer money with it. So these type of attacks could happen if same origin policy was not there. So what same origin policy essentially does is that it makes sure that the request is going from the same origin. So if you're gonna run this, if this request has to work, it should be from the banks.com website itself or from that host itself. We tried to replicate this, not SOP, but when we first created the web server, we were actually checking the host and stuff. So SOP basically checks all of that as well, where the request is coming from it, and checking if it is not coming from a third party site or anything like that. So that is basically same origin policy. Um, Now, but then again, it's really secure, but if you think about it, it is really restrictive. Like in the modern day, you want to be getting contents from different places. Maybe you will have images from facebook.com and or maybe some other website, and you will have some of your JavaScript libraries and fonts and color codes, so some stuff in another website which has all of these libraries, and you need to get it from all of those places as well, right? So there is a relaxation of same origin policy, and that is known as CORS or cross origin resource sharing. As the name itself means, you're allowing the browser, or you're allowing the entity to take resources from multiple areas, or to share resources from multiple areas without the same origin policy, like saying, hey, you should not get all of that. Think of it like a relaxation of the same origin policy. All right, so basically that is all about same origin policy and cross origin resource sharing. And there are some headers in CORS. So cross origin resource sharing, if I go to the developer.mozilla has a lot of good content. I would really let anyone know, check this thing out. So I'm just going down, accept, okay, allow. Yeah, so these are some of the headers that you can. So there is, allow access control origin header is there, so you can put it to star, or maybe you can put it to https bank.com, so it will only allow from bank.com. And if you put star, it will allow from any place. Like you can send, it will take origin from anywhere, so you should never be putting that. So these are some of the headers that are there which implements the cross-origin resource sharing. So if you want to send your credentials across, maybe your cookies or maybe your token, you can use your access control allow credentials. Then there are allow headers. So there is something called a pre-flight request or an options request that happens. So when you send that request along, it the server will respond back by saying, hey, which all headers or which all headers are allowed, basically. So yeah, that's kind of what it means. Yeah, this is what I was saying. So the methods will allow, like, if you can send, get, post, or put, whichever is allowed there as well. So it's kind of like, and the max age of the request, the time, and the connection will stay open and things like that. So check these things out. Now I will switch to the actual vulnerability which we'll be discussing. That is on a Flask. If you don't know I think most of you might have used Flask. If you haven't, it's kind of like a service which opens up APIs so that you can, your backend can communicate with your front end. So Flask basically does all of that. And Flask has many modules. Out of that, one module is actually for creating the CORS policies. So we have something called Flask-CORS, and it doesn't have much files. It's implementing CORS policy per se. So it's having its documentations and its core files and decorator extensions and versions and things like that. The main thing what this package is trying to do is implement CORS. So if you go to the file, and I'll just close this place as well, and I'll just turn off this thing. And this vulnerability actually happened in a version of 4.0.1, and I got the particular package, and I I did a git checkout to this particular commit so that I can see the vulnerable code. So I'll just close that, and I'll see. So I'll see the implementation right now. So the bug is mainly in the core.python file. This is the main issue right here. Actually, they have created something called access control allow private network. Think of it like, you have a public network and you have an internal private network as well. And if you want to communicate from public to private, you use this header. All of the CORS values will be sent as headers. So you will request a pre-flight request. A pre-flight request is called an options request to the server. It will send you back what all methods you're allowed to use, what all headers that you are allowed to send as well. So all of these are headers: access control list, origin, methods, allow headers, expose headers, things like that, credentials, max age. So out of this is the one that is vulnerable. That is the access control allow private network one. Okay, now that you understood what private allow control allow private network does, so say you are accessing an internal API in a private network and you are sending requests from the public facing you are in a public facing website which is sending a request to this endpoint, and if you are actually added in the CORS, then you will be allowed to grab data from the internal endpoints basically, or the private endpoints. Private endpoints are the ones that are behind the security guard per se. Okay, so now if you go down here, hello headers, you can allow any of the headers, things like that. So these things can be configured as per your liking. So you do have another file called a configurations RST. This contains kind of the default settings that is used for, default values is allow all headers true, CORS always send star, automatic options should be true, expose headers none, and they kind of set everything up like default. If you want to change these things, you can change this as well. So by default they are setting the value of let me just go here, and if I go down, they are just checking the origins here, get course origins, and get allow headers, get course headers. So they are checking the origin headers, expose headers, credential headers, and things like that. See, this is the options request or the pre-flight request to check what all are allowed in your code. See, max age, how much time should all of this be allowed, or how long you can does the auth work and things like that. Let me go down here. I think it should be in set course headers. You have a refix, try, match any, course options, flexible string, CLIs options. Okay, where are you? Where are you? Oh, okay. You know what? Why am I even doing all of this? I think I should just search for private. Yep, yep. 1, 2, 3. Yeah, see, this is the problem actually. I think I haven't checked much into it, but I think they added private thing kind of in these versions, so they didn't do much checks here. So let's check what is happening. If access control list request header private network in request header, so if that is in the request headers, and the request headers dot get, if the and they are getting the headers dot get, that they're getting the value of the particular header, and if that is equal to true, then they are presetting it as true. So it's basically, say if you are a malicious person and if you're sending in a request along and you are presetting, hey, I will set the private allow private network to be true, then that's what it's gonna take. It's not doing a validation. Ideally it should have been like, they should have preset this thing as false in the configuration, and then they should have made a secondary check here as well. That would have kind of helped them negate the vulnerability, because this is by default being set as true. And in the configuration also it's being default as true. So if you have this header coming in, it would be treated, that request will be treated as, hey, you can access the internal endpoints. So that is the vulnerability here. Let's kind of check how they fixed it. I had this thing here, GitHub commit. So let me see, they actually changed it to false in the patch. Actually, this is a later commit in version 5.0 that I'm looking at. I'll just increase the size as well. They made changes to the configurations, the core, the version, yeah, and testing as well. So so I did check the current configuration file, so it didn't had this particular value there. So I think it is in a later commit that this is happening. Maybe I said in beginning itself, which is version 4.0.1 that I'm checking right now, but this was done in, I guess, 4.0.2. So by default they are setting it as false. See, allow private network again as false in core.5. So they are explicitly defining it there. Yeah, see, this was in an older version, and in the, I think this is a test, right? This is a test. This is a default behavior how to allow private network access. Test default, they are checking for the origin and headers. If it is true, self-assert ACL response private network in response headers, and self-assert get ACL. So they are checking it in once, and yeah, they are checking it self-assert false. So they are asserting it as false, and that's it. So That's kind of solves it because they are preset. The vulnerability was arising because they were setting it as a default to be true. So once they changed that, they were able to fix it. So this is kind of the vulnerability that is here. I tried to test this out in my local environment, but it was not really working. So that's why I'm not going to be attaching a POC with this. This is kind of the vulnerability, and it has been awarded a bug bounty in Hunter. So this is kind of the submission. You can check this one as well. I will be linking it uh, in the description as well. Thank you so much for watching. Take care. Bye.